to Water 101 with Miss W. This is a little quick review for you guys over everything that you need to know about water. So what is the big deal with water anyway? Well, it's important to all living organisms, and you're going to see that little water molecule pop up when we talk about photosynthesis and cellular respiration. You're also going to see it when we talk about building and breaking down biomolecules. In fact, you're going to see water pop up several times this year. So we know that it's important for all living organisms. You also know that you have to drink water every day for survival. Why is our planet the only planet living organisms in the solar system? Water is one of the big reasons here. We all need it for survival, so let's look closely at water and its properties to see why it's the most popular molecule on the planet. First, we're going to study the chemical formula of water. You guys all know it. You've heard it several times in your life, probably, H2O. But what exactly does that mean? Well, it means that it has one oxygen atom and two hydrogen atoms. I like to say that it looks a little bit like Mickey Mouse. This is how I help remember the structure. And it is in a V like this, with the oxygen and the two hydrogens on the other end. These atoms are held together with a covalent bond, which means they're sharing electrons. The electron that normally is in the outer ring of hydrogen is being now shared with oxygen's outer ring as well. Same with this hydrogen. Well, what's special about this water molecule is that oxygen is actually going to be pretty greedy. It's going to bring those electrons closer to it, and they're going to actually spend more time orbiting around oxygen than they do the hydrogens. And because electrons are negative, and now oxygen is going to have more electrons around it than it does have protons in its nucleus, it's going to create a slightly negative charge on that part of the molecule, which leaves our hydrogen, who don't get as much time with the electrons, to have a slightly positive charge. So this is called polarity. Just like you think the north and south poles, think two poles with opposite charges. We have our negatively charged oxygen pole, and we have our positive charged hydrogen pole. And this is going to be very important to all of the different properties that water has created from this polarity. So let's take a closer look at that. The first thing that we need to know is because of these polar ends that water has, it's going to stick together with these bonds called hydrogen bonds. So, as I mentioned before, we have a negative charge on the oxygen and we have a positive charge on the hydrogens. Well, hydrogens of one water molecule are going to stick or be attracted to the negative charge oxygen on another water molecule. And that's going to create what we call a hydrogen bond. Now, these are weak bonds, and they're just held together by attraction, but because they're weak, they're kind of spread out like this. And this is going to just keep going until you have a bunch of water molecules all sticking together, and that's how we get our glass of water. This is why water stays together. And this unique property is going to lead to a bunch of characteristics or properties of water that are caused by that hydrogen bond or the polarity of it. So because of those properties, we get strong cohesion, strong adhesion, a good solvent, low ice density, and high capacity of heat. Well, what do each one of these mean? Let's take a closer look. First, let's look at cohesion and adhesion. When water is sticking to itself, which we now know is from those hydrogen bonds, that's called cohesion. It creates surface tension. So this is why if you've ever been out to a pond or lake and you see those insects able to float across the top of the water, that's because of that surface tension created by the water. In fact, you can practice this at home. If you go get a glass of water and take a piece of paper, a small piece of paper, and just add it to the surface of the water, it'll float for a little bit until it gets completely soaked through. So that is surface tension created by those hydrogen bonds, that water sticking together to itself. Another thing that water does is it'll stick to other stuff, and this is called adhesion. Why is all this happening? Well, again, it's that hydrogen bonding. That hydrogen bonding creates a bond between the water and another molecule, or it can even create a bond between the water's attraction to another surface's attraction. And that would also be a hydrogen bond, but instead of it sticking from water to water, it's going to stick from water to whatever surface that it's on. For example, a glass or a paper towel. Well, these two things together, cohesion and adhesion, are going to have a really cool effect called capillary action. And I've got a little video for you guys to view. Here is that the water from one glass is able to travel up through the paper towel into the other glass. The same thing happened over here. And the reason that that is happening is because, first of all, water is adhering to the paper towel because of the polarity in it, because of the attraction, and then because it is cohesion, because of cohesion, it's sticking to itself, it's going to just pull up more water through the paper towel into the other glass. Very cool. The next property that we're going to talk about is water being a good solvent. And really, it's not just good. It's awesome. It's called a universal solvent. And now, I know what you're wondering. What is a solvent? Well, a solvent dissolves solutes, creating solutions. A solvent is going to be something that dissolves other items. The solutes is going to be what is dissolved, and then once that has happened, the solutes have dissolved in the solvent, you're going to get a solution, okay? And that's just whatever, for example, water, whenever you dissolve salt. So water would be the solvent, salt would be the solute, and the solution would be salt water. And the reason that this happens is because of the polarity of water. So if you look closely at my diagram over here, I have some sodium chloride. And this is a salt molecule. We have the positive sodium and the negative chloride, and they're being held together by an ionic bond. Well, again, we have charges here. We've got the negative chlorine and the positive sodium. So what happens is water comes in, and its negatively charged oxygens are going to surround that positively charged sodium atom and pull it away from the group. On the other end, we have our positively charged hydrogens surrounding a negatively charged chlorine and pulling it away from the group. And this is going to continue to happen until that entire salt molecule has been dissolved into the water. So what exactly dissolves in water? Well, there's a good term that you guys should know, and that's like dissolves like. We've talked about water being polar, so anything that's going to dissolve in water, or what we like to call soluble in water, is going to also need to be a polar molecule. What do we call something that will dissolve in water? Well, we call that hydrophilic. Hydro means water, and philic means loving. So anything that is actually going to dissolve in water, we have a little term for that, and that is hydrophilic. It loves to dissolve in water. On the flip side of that, we have things that won't dissolve in water. So same thing here, like dissolves like. If water is polar, what's not going to dissolve in it? Well, anything that is non-polar. This is going to be considered insoluble, or in other words, it will not dissolve in water. And what do we call something that will not dissolve in water? We call it hydrophobic. So hydro meaning water again. And then this time we talk about phobic, which means fearing. So literally, items like oil are going to be water fearing. They cannot dissolve in water because they are a non-polar molecule. And you're going to learn that again. All of our lipids from our biomolecules are non-polar for the most part. Another quality is, or another property of water is that it's low ice density. And this is super weird, okay? Most solutions, when they are in solid form, are more dense than their liquid form, meaning that they would sink. But ice is odd in this manner. Instead, it floats. And what happens here is, again, this is caused by hydrogen bonding. When those things start to cool, the hydrogen bonds actually stretch a little bit. And because they're stretching out a little bit, we have space between each individual water molecule, which gives it less density. And this is very important to life. If it had been the other way around, if you take a look at my fish diagram here, if it were the other way around and ice sunk to the bottom, it would sink and continue to freeze up until we have barely any water for the life to survive in. On the other hand, we know that ice does float. So what happens is that ice will create a layer on the top of our lake and it'll freeze, but then everything below that layer is going to be fine. It's actually going to create an insulation barrier and keeping that below water slightly warmer than the outside temperature, allowing for that life to survive. So this is a very unique but awesome and important quality that water has. The other thing to touch on is the high heat capacity. Basically, water can absorb a great deal of heat with little rise in temperature. And again, this happens because of the hydrogen bonds. So much heat goes into breaking those hydrogen bonds before the actual water molecules will heat up or cool off. So again, this quality happens because of the hydrogen bonds, but it's important to know that this happens allowing life to survive in our water ecosystems. Think about your body here. Your cells in your body is made up of a lot of water. If you froze or heated up to the temperature outside quickly, you would not survive. So it's a good thing that water, it takes a lot to heat up water or cool it off. So some takeaways here for this lesson is water is important to all life processes. It is special because its unique structure and its hydrogen bonds. It has unique properties that make it an awesome molecule. And just a heads up, you'll want to know these properties that are in this video, and you're going to want to pick one to know really well and be able to describe the chemical and physical properties that cause it to have that property, that specific property. So pick your favorite one and get to know it really well. Make sure you talk about its polarity and its hydrogen bonds, and you're going to want to know that for your upcoming test. If you guys have any questions on this, feel free to reach out. Thank you so much for watching.